In this video, we are going to review how to graph and write exponential functions. So the first thing we're going to do when we are graphing exponential functions is we have to create a table of values in order to get points to plot on the graph. When we create our table, I'm going to look at example number 1. Your table always will have the same x values, ranging from -2 all the way to +2. What we're going to do is take each one of these x values and plug it into the equation to get the y values. The first x value I'll plug in is -2. So I would have 1/4 times 3 to the -2nd power. As we know from exponent properties, we cannot have a negative exponent. In order to make it positive, we have to put it to the bottom of a fraction. So I'd end up with 1/4 times 1/3 squared. 3 squared is 9, so I'd have 1/4 times 1/9. When you multiply the tops and bottoms, we end up with 1/36. Same process when I plug in -1. I'd have 1/4 times 3 to the -1st power. You cannot have a negative exponent, so we move it to the bottom of the fraction. We take the reciprocal. So it's 1/4 times 1/3. 3 to the 1st power is 3. So when you multiply the tops and bottoms here, 1 times 1 is 1, 4 times 3 is 12. So I'd have 1/12. When I plug in 0, I'd have 1/4 times 3 to the 0. Anything to the 0 power is 1. So it's really 1/4 times 1, which is just 1/4. If I were to plug in a positive 1, I would have 1/4 times 3 to the 1st power. Now this is not a negative exponent, so I do not have to take the reciprocal. I can just turn it into a fraction and multiply the tops and the bottoms. 1 times 3 is 3, 4 times 1 is 4, so I'd have 3/4. If I plugged in 2, I'd have 1/4 times 3 to the 2nd power. Again, it's not a negative exponent. I do not have to move it to the bottom of a fraction. I will evaluate that 3 to the 2nd power is 9, and I could turn that into a fraction by putting it over 1 and multiplying tops and bottoms. 1 times 9 is 9, 4 times 1 is 4. So that's how you create the table of values. Now we have to plot the points. Now, fractions sometimes can confuse us. As long as you know which two numbers it is between, you will be okay. The way you figure that out is you see how many times the bottom number of the fraction goes into the top. 36 does not go into 1 evenly, so I know that's somewhere between 0 and 1, a lot closer to 0 than 1. So I go to -2 on the x-axis, and I go up just a very, very little bit, and I'll put a point. 12 also does not go into 1. So again, when I go to -1 on the x-axis, this will just be a tad higher. Zero 1/4. 4 does not go into 1. It's still between 0 and 1, but it'll just be a little bit higher. Once again, 4 does not go into 3, still between 0 and 1, just again a little bit higher. Now for 2, 4 goes into 9 twice with some left over, so it should be somewhere between 2 and 3. So if I go to the x-axis at 2 and I go somewhere between 2 and 3, put that point. You want to draw a smooth curve that does not cross the x-axis. That continues on forever. This would be exponential growth, and we can tell by a couple ways. One, the b value of 3 is greater than 1, or our graph increases from left to right. Now we will do an example of a decay problem. Number 2. Again, you want a table of values. Your x values will range from -2 to +2. And we're going to take each x value, plug it in for x in our original problem. First x value I'll plug in is -2. So I'll have 4 times 1/2 to the -2nd power. Outside exponent should be multiplied by each of the inside exponents. Remember, there are 1 exponents if there's nothing written. So I end up with 4 times 1 to the -2nd over 2 to the -2nd power. You cannot have a negative exponent. In order to make them positive, you need to take the reciprocal. So move 1 to the -2nd to the bottom, and move 2 to the -2nd to the top. So I end up with 4 times 2 squared over 1 squared. 2 squared is 4, so I have 4 times 4. 1 squared is 1 over 1. When we turn the original 4, the a value, into a fraction, and you multiply tops and bottoms, you get 16 over 1, which is just 16. If I plug in -1, I'd have 4 times 1/2 to the -1st power. Again, you distribute the outside exponent to each of the inside exponents. So 4 times 1 to the -1st over 2 to the -1st. We cannot have negatives, so we take the reciprocal. Bring the negative exponent from the top to the bottom, and the one that was originally on the bottom we would move to the top. So 4 times 2 to the 1st, which is 2, over 1 to the 1st, which is 1. Multiply the tops and bottoms. 4 times 2 is 8. 1 times 1 is 1. 8 over 1 is 8. If I plug in 0, 4 times 1/2 to the 0. Anything to the 0 is 1. So I have 4 times 1, which is 4. 2 more, so if I plug in the first power, 4 times 1/2 to the 1st. Distribute outside exponent to the inside exponents of 1. 4 times 1 to the 1st, which is 1, over 2 to the 1st, which is going to be 2. We don't have to take the reciprocal here because there is not a negative exponent. We would multiply the tops and the bottom. 4 times 1 is 4. 1 times 2 is 2. 4 divided by 2 is 2. The last one we have to plug in is +2. So 4 times 1/2 squared. Once again, multiply the outside and the inside exponents. 1 squared over 2 squared. Once again, no reciprocal is needed. We have positive exponents. So it's 4 times 1 squared is 1, 2 squared is 4. Tops and bottoms.